Okay, so when we do oxidation redox reactions, we call them redox reactions, we look at what is happening to electrons, where they're going, where they're moving from or moving to, okay? And eventually you're going to have to be able to write what's called a half reaction, and to do that, this is a little mnemonic device to help you, okay? And so what oil rig stands for, oil stands for oxidation is losing. What is it losing? Electrons. Okay? Oil stands for oxidation is losing. Rig stands for reduction is gaining. What is it gaining?
Negative.
Electrons. Okay? Now, these are all characteristics, and you can use that mnemonic device to help you out. What I like to use is this second one. It just makes the most sense to me. Okay? Because in oil and oxidation, you're becoming more positive. That ion is becoming more positive. In reduction, that ion is becoming more negative. That's what I like to use. If you don't really get it and you want to try one of these other ones to figure out what's being reduced and what's being oxidized, you can do that, but that's what I like to use. Okay? So, from these equations, after we found oxidation, you'll be able to answer 4 questions for me. Are you ready? Those 4 questions are, what's being oxidized? What's being reduced? What is the half reaction for oxidation? What is the half reaction for reduction? And really, once you find one, you find the other one for the first kind of set of questions, and then the same with the last one. Okay? Oxidation and reduction always occur in pairs. So if you're doing your homework or your test, and you say, okay, I found what's being oxidized, but nothing in here is being reduced, that doesn't make sense, because they're always in pairs. You did something wrong. Okay? So that's a good thing to remember. All right. So here's a step-by-step process of what we will be doing with these reactions and how we're going to find them. Okay. Notice how the first step is to find the oxidation states of each one of the elements. That's what we just did. That's why we just did it. And really, that's why if you struggle with it, you need to practice more, because if you can't do that skill, you don't have that skill, none of the rest of this is going to work out for you. Okay? So, find the oxidation states, and then you got to look at, do you have a change on your reactant side to your product side? Is there a change of charges on your left to your right? If your answer is yes, then you do have what we call a redox reaction. If you do not, you don't have a redox reaction. That means all the stuff that we're about to do doesn't occur. Does that make sense? Well, it will make more sense once we do it. Okay? And here's a little heads up. You ready? The only ones that will have no change in oxidation numbers are your double replacement. So if I ask you to do a redox half reactions for a double replacement, your answer should be double replacement isn't redox. Okay, because the electron numbers, oxidation numbers, aren't going to change. What other type of double replacement do we know of? What is it? Combustion is not neutralization. So when you have an acid base come together, is that redox? It is not, because that's a type of double replacement. All right? We need to balance the equation, and then step 4 and step 5 are going to be the brand new stuff for this part of the lesson. Separate the overall reactions into half reactions, and then balance using use electrons to balance. So we're going to be adding electrons to these equations to make sure they're balanced after we've pulled them out of the normal equation. Okay? Sounds like a bunch of crazy talk until we actually do it, which is usually the theme of the class, right? So here we go. Is this a double replacement reaction? So should we expect a redox to occur?
Yeah.
Yes. Okay, that's the first part. Step one is to do all of the oxidation numbers for every element up there. Yes? So what's your oxidation state of magnesium, Jacob? Is it bonded to something? So anything in its free state is always what?
0.
So you do know. Which makes sulfur what, Jacob?
Also 0.
Also 0. So that's what you're going to do. And just a heads up, your small writing skill is going to be essential. Because you're going to be writing these oxidation numbers above each one of these things. And hopefully you can read your own writing. Okay? Because you're going to have to be able to do that. Right? So now when I get over to magnesium sulfide in the product, are these in their free state anymore? So now we need to look at oxidation numbers and how they got there. Well, magnesium falls in family 2, right? Group 2. Does it have a rule to it?
Yes.
What is it always?
It's always going to be like +2.
It'll always be +2, right? Alkaline earth metals. Does magnesium sulfide have a charge to it? So we're thinking its overall charge has to be what?
0.
0, which means sulfur has to be what?
-2.
You see why that little worksheet is so important, right? Being able to find oxidation numbers. So now that we have the oxidation numbers, we have to look at has the charges changed from the reactants to the products. What do I mean by that? Magnesium starts at what? 0, and it turns into what?
+2.
Is that a change?
Yes.
Yes, it is. Sulfur
0
to
to -2.
-2, is that a change?
Yes.
Yes, it is. So this is an extremely simple example. It's the first one, very simple. You're gonna need some very big equations to where you have a bunch of stuff in there that you can cross out, and you're only gonna be able to find 2 changes, okay? So what I'm gonna suggest you do, connect your magnesiums and connect your sulfurs. That shows you that those are the 2 things that I see changes in. Once you have found 2, stop. Because there's only one thing being reduced and only one thing being oxidized. Okay, you can stop right there. So now, if I remember, oxidation is becoming more what?
Positive.
Thank you for looking at your notes. More positive, which means reduction is becoming more negative. And for a while, you might have to write that down every time you do one of these just to make sure you're doing it the right way until you really memorize it, okay? So if oxidation is becoming more positive, which element is being oxidized? Magnesium, 0 to +2. Is that becoming more positive or more negative?
More negative.
0 to +2.
More positive.
More positive. So what is being oxidized? Magnesium. Because it's becoming more positive. Look at the transfer of electrons, the change of electrons, I should check. Which means reduction is becoming more negative. Let's just check it. Sulfur 0 to -2. Is that becoming more negative?
Yes.
Yes, it is. So sulfur is being reduced. So right now you've answered 2 of the 4 questions. What's being oxidized and what's being reduced. You will be asked it in that direct way on your quiz and test coming up. Okay? The next one is, what are the half reactions for each one of these, oxidation and reduction? So what we need to do here is say, okay, magnesium starts out as 0 and sulfur starts out as 0. Correct? Reduction is the easier one to think of, and it makes more sense when we do it this way. So sulfur plus what will give me an S-2 charge. We need to balance using electrons. So what do I need to add in this spot to give me sulfur -2?
-2.
2 electrons, right? 2 negative things. Those negative things are electrons, so 2 electrons. See how we balanced it? To balance sulfur with no charge and sulfur with -2 charge, I need to add 2 electrons. Now the oxidation comes a little bit more tricky to think about. Because we can't say magnesium -2 electrons, because we can't put minus symbol signs in a chemical equation. Okay, we can only do plus. To get this to work out, we have to say magnesium, the product of magnesium is magnesium +2 when 2 electrons are kicked off of it. That's a little bit more difficult to think of. But because we can't put subtraction signs in a chemical equation, we have to kind of flip the equation here. Magnesium 0 produces magnesium +2 when it gets rid of 2 electrons. When 2 electrons are produced off of that magnesium. Okay? Here's my suggestion to you. If you understood what I just said about your oxidation equation, then great. If you didn't, do the one that makes sense to you, and then just kind of do the opposite on oxidation. Put the arrow first, then figure out how many electrons you need to add to that side of it. Okay? So, being oxidized, being reduced. Oxidation half reaction using electrons. Reduction half reaction using electrons. Okay? Let's do another one. So what's my charge on aluminum? Ellis? Ellis? Why? By itself. Right? Porter? O2.
Oh, it's 0.
0. Why?
It's by itself.
By itself. And diatomic though. That's still a rule. By itself, right?
It has to-
Aluminum on my product side. Aluminum on my product side. Preston? How about this? Oxygen on my product side.
It's 0. Or
It's
negative-
bonded.
Or negative.
Right? Because oxygen is always -2. Which means if I do the math, what does aluminum have to be?
+2.
+3.
Oh, yeah.
+3, right? So now I got all my oxidation numbers across. Now I got to see if there's been any change in oxidation numbers from the starting element to the ending element, right? Aluminum starts at 0, it turns into what? +3. Is that a change?
Yes.
Connect them. Oxygen starts at 0, turns into -2. Is that a change? Connect them. Okay? So now we got to figure out, once again, write it down if you need to. Oxidation means more positive. Reduction means more negative. So if I start just with aluminum, because that's the one that appears first, aluminum goes from 0 to +3. Is that being oxidized or reduced?
Aluminum's been oxidized.
Aluminum.
Oxidized.
Oxidized, right? Aluminum is being oxidized. Have you guys figured out that oxygen or oxidation doesn't always occur with oxygen? There's no correlation there, right? Don't think of it that way. Which means, what's being reduced? Oxygen. Because it's becoming more negative. So you just answered 2 of the 4 questions. Now let's go back and do the half reactions. Start with reduction if you want to. Oxygen's being reduced. It starts O2. Starts at 0 plus how many electrons? We need to get to -2.
Plus 2.
2 electrons will give me oxygen, and we can get rid of that O2 because this is just a half reaction. So oxygen 0 plus 2 electrons should give me oxygen with a -2 charge. And that makes sense, right? That's how you balance using electrons. Now aluminum starts at 0 and turns into aluminum plus 3 by doing what? By losing what? By losing 3 electrons. Okay? A little better than the first time? All right. Now, let's see, a little bit more difficult one, because now you have a single replacement, and if you can only have 2 elements, one that's being oxidized, one that's being reduced, one thing up there isn't going to be used in your half reactions. Okay? So go ahead and try to do this one. Not a break, so you can't go there. You can't go there now. All right, so some of us are kind of struggling just getting started. What's my first step that I've got to do before I start looking for anything? I got to do oxidation numbers for each one of these up here, right? That was the skill that we learned just a little bit ago. So on my reactant side, what's the easy one to do first? Copper, why? Because by itself is 0. Yes? And AgNO3, I got to be able to pick out that nitrate, right? Then I go to my polyatomic ion chart. What's the charge of nitrate? -1, right? So overall that's going to be -1. If that's -1, then what does silver have to be? +1. So now the hard part is finding the nitrogen, because oxygen is always going to be what? What's oxygen always going to be?
-2.
-2. So now if I do a little bit of math, nitrate has to equal -1 because that's the overall charge of it. Nitrogen plus 3 oxygens with a charge of -2 each nitrogen plus -6 has to equal -1. Which means what does nitrogen have to be? +5. Okay? Now go to my product side. What's the easy one there?
Silver is
Because it's what?
by itself.
0. What if I told you that there's another extremely easy one?
It'd be copper.
Nope. Nitrate. Why? You've already done nitrate. So do we have to redo the math for all of nitrate? No. +5 -2. Guess when you go to your test in a week and a half and I put a nitrate on there, guess what it's going to be?
Same thing.
Same thing. Look at the other homework page I just passed out to you. Every time you see nitrate on there, guess what it's going to be? +5 -2. Okay? So do you have to memorize these? Absolutely not. But if you can, you just save yourself a whole lot of headache in math. Okay? Or once you do it one time, keep looking back at it to redo it throughout your test or your homework, whatever it may be, to save yourself some time. Okay? So now that I know this nitrate is -1, what does that copper have to be?
+1.
No. Why? Because there's 2 nitrates, right?
It's +2.
So copper has to be what?
+2.
Be careful. Good catch. Everybody see why it's +2? Because nitrates, there's 2 nitrates, so it's bringing a total of -2, so we have to cancel out both of those negatives with a +2. Right? So now I'm ready to figure out what's been oxidized and reduced. When I go to silver, silver's +1 and it's 0 over here. Is that a change?
Yes.
Connect them. Nitrate here and nitrate here, did anything change with inside of them? No, so I can pretty well cross those out. There's my thing that I'm not using. Copper, 0 to +2. Is that a change? Connect them. Okay, so let's start with silver. +1 to 0. Is that becoming more positive or more negative?
More negative.
More negative, which is what? Oxidation and reduction. Reduction. So what's being reduced? Silver. Which means what's being oxidized?
Copper.
Copper. And actually, what type of copper?
Copper
Copper 2. But copper's okay right now. If you want to be super technical, you can put copper 2. Right? So now I need my half reactions. If we want to start with reduction, we start with Ag +1 that plus what will give me Ag 0?
1 electron.
1 electron. So there's your balanced reduction reaction, half reaction, using electrons. Now if we go up to the oxidation, we start with copper 0. To get that to copper +2, what did we need to do? Kick off 2 electrons. Kick off 2 electrons. Oh, 2 electrons. To make it balanced. All right? Not terrible? Kind of terrible? All right. Go to the sheet that I just passed out to you. All right. There's a bunch of them on here, and you see how they get bigger? Yes? So being able to cross out and those connections that we made, that's going to be vital. That's why even though they were very small up there, that's why I said make the connection. Once you've made 2 connections, you can stop looking for any changes. Now look at the back of that sheet. What do you see? The answer key. Right? I did that for a reason. Because with this specifically, if you don't do this on your own and use that answer key the right way, it's going to go right by you. Like you don't have a chance with this if you don't practice this and use that answer key the right way. If you copy straight back, you don't even need to find somebody to copy from now because you have the answer key right there. Right? Not that any of you would ever copy from anybody. Right, Casey?
Yeah.
Good. But if you do copy from that, you don't, you're going to be done with this. Okay? You have to do this by yourself. You have to struggle through it a little bit to get it right. Some of these get very tedious, like number 9. I'm going to do number 9 with you right now, okay? And it's nothing different. It's just a little bit more finding oxidation numbers than what we just did, okay? So the first step is to balance if you can balance, if you need to balance. The good thing for you is that these are all balanced already, okay? You don't need to worry about that for this homework. What you do need to worry about is finding the right oxidation numbers for each one of these elements in here. The key to this is to find repeats, right? Find repeats. So I start here. Manganese and nitrate. Manganese, nitrate, right? So I start with, does manganese really have a rule? So I go to nitrate. Well, guess what? Guess what we just did? What did we just do in our notes? Nitrate. Is it going to be the same oxidation numbers here?
Yes.
Yes, it is. So if you were following along in those notes, that's great because you'll see that nitrogen is +5, oxygen is -2. And if you find nitrate, and there's a couple examples up where there's more nitrate, use it again. Once you've done chlorite, do chloride again if it's found somewhere else. Sulfate, sulfite, any polyatomic ion that you do multiple times, you can repeat those numbers. Now, my caution is, make sure you do it right. Because if you do it wrong here, and you copy it over, you're going to just keep copying it wrong. So make sure you do it right the first time, right? So if this is -1 overall, what does manganese have to be? What is it?
+2.
Because there are 2 nitrates. Does that make sense? Over here, BiO3 is bismuthate. You ever heard of that before?
No.
Me either. Not until I found this homework. Okay, so I looked it up for you, and it has an overall charge of -1. And just a heads up, anything that's given on the test or your quiz, you'll be able to look up on your chart. I'm going to give you something crazy like that. Okay? It's -1, which means right away, what does sodium have to be?
+1.
But let's say I didn't give you that -1. Could we still be able to figure out the overall charge of that, whatever that is?
Yes.
Because sodium, does it have a rule?
Yes.
+1, which means that polyatomic ion has to be what?
-1.
Are we done?
No.
We still have to find the charges for bismuth and oxygen in here, right? Well, oxygen is always going to be what? -2. That's a good thing. So now if I do a little bit of math, Bi plus 3 oxygens -2 each has to equal -1. -6 plus bismuth has to equal -1. What does bismuth have to be? +5. Okay? So we're good there? Oh, look, HNO3. What's good about that?
We already know what
We already know what nitrate is, right? What is it? +5 -2. Hydrogen has to be what?
+1.
And that's a rule for hydrogen too. And it makes sense because nitrate is -1. There we go. Now when we get over here, we have, is that permanganate? MnO4? It's on your chart.
Yes.
MnO4 is a polyatomic ion.
-1. Has to be -1.
MnO4 is -1. minus 1, which means hydrogen is plus 1. When I do the math, manganese plus 4 oxygens has to equal negative 1. Correct? So when I do the math, manganese plus negative 8 has to equal negative 1. What does manganese need to be?
7 plus
Positive 7. Oxygen is minus 2. Now, we get to bismuth right here. Is that bismuthate in the polyatomic ion? Is that different?
Yes.
It is. So do we know for sure that it's plus 5? We don't, because it's not attached, it's not with a polyatomic ion. So we need to go over here first. Well, nitrate. What's nitrate?
Minus 1
Plus 5 minus 2, again, right? But how many nitrates do I have?
You have 3.
So overall, this is carrying a minus 3 charge with it. So what does bismuth have to carry to cancel out minus 3?
Positive 3.
A positive 3. Okay? Then I go over here, nitrate again. Plus 5 minus 2. Sodium has to be what?
Positive 1.
It's a part of our rules as well. It's always going to be positive 1. And then I go over to water. Well, oxygen has to be minus 2. That's not peroxide. So what does hydrogen have to be? Plus 1, because how many hydrogens are there?
2.
So plus 1 minus 2 give you 0. Okay? So that's all well and good, but we haven't really answered anything yet. We haven't done anything with the answer. For each one of these, this is how you're going to answer each one of these. I need to know what is being oxidized and what is being reduced. So let's start there. Manganese, plus 2. Find manganese over here, plus 7. Is that a change?
Yes.
Connect them. Did my nitrates change at all throughout the entire equation?
No.
So I can cross all of those out to make it look a little better. Sodium, plus 1. Sodium, plus 1. Did that change? Nope, that's not what I'm looking for. Hydrogen, plus 1, plus 1. Did that change? Did my hydrogens change?
No.
Nope. I skipped over here at bismuth. Plus 5, plus 3. There is my second change. So, do I need to look for anything else?
No.
Once I found 2, I'm done. Okay? Now I need to look at manganese, plus 2 to plus 7. What did that do? More positive or more negative? More positive, so that explains what?
Oxidation.
So, what's being oxidized? Manganese. And then, which means what's being reduced? Plus 5, plus 3, that does check out because that's becoming more negative. Bismuth is what's being reduced. Okay? So being able to pick those two things out will give you a good amount of points on a free response question. To get all the points on that free response, manganese starts at plus 2. And to get to manganese plus 7, what did I do? Yeah. Say it. I kicked off 5 electrons. You see how that works? Negative 5 plus 7 should give you 2. It's balanced. For bismuth, I start at plus 5. How am I going to get to bismuth plus 3? 2 electrons. And there you go. Now your directions to this page might say like the oxidizing agent or how many electrons were lost or gained or whatever. Don't worry about that stuff right now. These are the 4 answers I want you to have for each one of these problems. Okay? The answer key is on the back. I fully expect all of you to use the answer key at least once or twice while you're going through it, and then to check your answers when you're done with them. All right, that's how you use an answer key. But once again, if you're copying straight from the back, or you take your buddy's paper and just copy it all down because you're so lazy you can't flip it over to copy, this is going to go right over your head. And this is not one of those things where if you sit back today, if you kind of were in and out of sleep today, you're going to have to go back and listen to the video because you're going to miss everything. Okay? But the video's up. Go watch it if you need to.